Hello, my name is Amory Lenahan, and I did my project on the most bizarre discoveries of extrasolar planets. Extrasolar planets, or exoplanets, are planetary bodies outside our solar system that orbit a star other than the Sun. The first extrasolar planet was discovered in 1992, but there are over 700 known exoplanets today. Exoplanets are very difficult to detect since they are outside our solar system. Most have elongated orbits rather than the circular orbits that Earth has around the Sun. Extrasolar planets are given names according to their star system, followed by a letter. Exoplanets experience the same struggles as Earth as their stars evolve towards the red giant phase. Scientists are using extrasolar planets in order to learn about the possibility of life on other planets as well as the fate of Earth when the Sun becomes a red giant. The first exoplanet that I studied was the TRES-4. It belongs in the constellation Hercules, and it is the largest planet discovered so far. TRES-4 is 1,400 light-years away from Earth and 1.7 times the size of Jupiter. It is called a puffy planet because of its gaseous state. It is an anomaly among exoplanets. Its existence cannot be explained. It circulates its parent star in 3.5 days. Its sun is a similar size to ours, but its sun is already in the subgiant phase. This means that it is a star that is slightly brighter than the normal main sequence or dwarf star of the same spectral class, but not as bright as the true giant stars. It is so close to its sun that it will be consumed once its sun reaches the red giant phase. The reason that this planet is particularly bizarre is because it is believed to be too large for its small density. It has the density similar to cork or balsa wood, even though it is almost 2 times the size of Jupiter. It is believed that its large size has something to do with the fact that its sun is hotter than ours, so it absorbs a lot more heat. The surface of TRES-4 is believed to be 2,300 degrees Fahrenheit. The next exoplanet that I studied was the PSR J17191438. This exoplanet belongs in the constellation of Serpens, and it has a similar mass to Jupiter. This exoplanet is 4,000 light-years away from Earth, and it is believed to be a diamond. The high pressure has probably caused the carbon inside the planet to crystallize, forming a diamond. It was probably once a star, but about 99% of its mass was taken away by a companion star. PSR J17191438 is about 5 times the size of Earth. It rotates around a millisecond pulsar. A millisecond pulsar, or an MSP, is a pulsar with a rotational period in the range of about 1 to 10 milliseconds. It is believed that the millisecond pulsar that this exoplanet circulates was originally a supernova. This is only the second system of its kind to be discovered, and it rotates at an astonishingly fast speed. It orbits the pulsar in a little over 2 hours, and the entire system could fit within the diameter of our Sun. The next exoplanet that I studied is the V391 Pegasi b. This exoplanet belongs in the constellation Pegasus. It orbits its sun at about the same distance that Earth orbits our Sun. It is a gaseous planet that orbits a white dwarf star. A white dwarf star is a star approximately the size of the Earth that has undergone gravitational collapse and is in the final stage of evolution for low-mass stars, beginning hot and white and ending cold and dark. It is the first planet found that has survived the red giant phase of its star, normally after the red giant phase. While its sun was dying, it probably orbited inside the dying star. This is what makes this exoplanet particularly bizarre. This planet is looked at as an example of what could happen to the planets in our solar system when our sun reaches the red giant phase. It cannot be seen directly from our universe, and therefore it took 7 years of observations and calculations to confirm its existence. The scientists that eventually discovered the V391 Pegasi b were studying the pulsations of its central star's light when they discovered the planet. The next exoplanet that I studied is the Sweeps 10. This planet belongs in the constellation Sagittarius. It orbits only 1.2 million kilometers from its sun, and its sun is a red dwarf. A red dwarf is any of the faint reddish stars having diameters about half that of the sun and low surface temperatures of about 2,000 to 3,000 Kelvin. This red dwarf star is smaller and cooler than our Sun. The Sweeps 10 is roughly 1.6 Jupiter masses, and it could hold 1,500 Earths. It has the shortest known orbit of any planet. It orbits its central star at 10 hours. It is called an ultra-short period planet because of this short rotation, otherwise known as a USPP. The estimated temperature on the surface of Sweeps 10 is 3,000 degrees Fahrenheit. It is believed that it can survive this close to its Sun because it can handle the surface temperature. The following exoplanet that I studied is the WASP 12b. This exoplanet belongs in the constellation Argyria. It is located 2.1 million miles from its Sun, while we are only 93 million miles from our Sun. It is 870 light years away from Earth, and this exoplanet is extremely hot. It makes a full orbit in little over an Earth day, and the atmosphere has swollen, causing the planet to become an egg shape. Its Sun has started to destroy the planet, tearing off pieces with the wind. It is in the last 10 million years of its life. It is believed that the rocks on this planet are made of pure carbon, causing them to be either diamond or graphite. Diamonds or graphite could be as common on WASP 12b as limestone is on Earth. The atmosphere is made up of carbon monoxide and methane, and it is possible that the core is a solid diamond. This exoplanet has the same fate that our planets will have when our Sun becomes a red giant. It is about 4,000 degrees Fahrenheit on its surface of this gaseous planet. Thank you for listening.